Hi everyone, welcome back to Cybersecurity Simplified. Today's question is about a concept that is becoming increasingly important in AI agents and agentic AI. Multi-agent systems, agent orchestration, graph-based workflow. And unlike some concepts that are difficult to visualize, today we are going to build and test a real workflow in Azure AI Foundry. Let's imagine we are building an insurance claim processing solution. Instead of one AI agent doing everything, we create specialized agents. Agent 1, document review agent. Responsibilities, review the claim, extract important information, create a claim summary. Agent 2, fraud assessment agent. Responsibilities, review claim information, identify fraud indicators, assign a risk level. Agent 3, decision agent. Responsibilities, review findings, produce a recommendation, determine next action. Important question. We now have multiple agents, document review agents, fraud assessment agent, decision agent. Who decides which agent runs first? Which agent receives data next? How information moves through the process? That's exactly what today's question is testing. Simple memory trick. Think of it like a company. Agent is nothing like a worker. Each worker performs a specific task. Workflow is nothing like a manager. The workflow decides who works next, what data get passed, where the process goes, how agents collaborate. Now let's build and test a real workflow. I'm inside Azure AI Foundry. We'll build, and then inside agents, you'll see workflow. Presently, it shows preview at this date, like July 31st, 2026. Let's click on workflow. I don't have anything, so let's create workflow. I will create a blank workflow. So let me click start here, and I need agent. So basically, we are going to create start, agent 1, document review agent, agent 2, fraud assessment agent, and agent 3, decision agent. So let's create first. As we don't have an agent, let's create one. Let's give a name. Create. Let's not put any instructions or anything at this stage. Let's create done. Similarly, we create other agents. Create a new agent. Done. Add agent. Done. Basically, we created 3 agents. Now let's define role of each agent. We go back in agents. Let's save. If you see, we have 3 agents. Let's create agent configuration for document review agent in system instructions. See, basically we are telling you are a document review agent for an insurance company, your responsibilities. We are not doing anything else. Let's save this. Let's set up for fraud assessment agent. System instructions. Again, we are telling him you are a fraud assessment agent. Review the claim summary received from the previous agent, fraud indicators. We're just defining some parameters. Again, we're not uploading any data or anything. Let's save this. Let's go back and let's update our decision agent. We're telling this agent his role. Review fraud assessment received from previous agent, decision rules. Okay. Save. Let's go in our workflow. Just preview. Now let's run the workflow. We are giving input data like process the following, claim, and other details. And let's see how this works. Now what happens? Document review agent produces claim summary, claim number, claim amount, previous claims, and document attached. Fraud assessment agent produces fraud risk estimator. It gives the reason, and then it passes to decision agent, which produces final recommendation, says that, oh, we need a manual review or human intervention. The prior fraud assessment classified claim under the workflow rule, manual review is required. Notice something very important here. I only submitted the claim once. The workflow automatically moved data through document review, fraud assessment, and decision agent. The workflow controlled the handoff. The workflow controlled the routing. The workflow controlled the order of executions. What is a graph-based workflow? It's like start, document review agent, fraud assessment agent, decision agent. Every box is a node. Every connection is a transaction. Together, they form a graph. A graph-based workflow defines data flow, control flow, routing, state hands-off, agent-to-agent communication. The workflow decides who works next, what data is passed, and where the process goes. Now let's answer today's question. In a multi-agent orchestration design using Microsoft Agent Framework, which component defines how data and control flow between agent A and agent B? Let's eliminate wrong options. Option A, a thread stores conversation history. Think like a chat context. Thread helps maintain context. They do not orchestrate agent. Option C, vector store. Vector store provides retrieval, search, embedding, knowledge access. They help agent find information. They do not define agent routing. So this is wrong. D, system messages. System messages defines agent behavior, instructions, personality. Example, be professional, be concise, respond in English. System messages influence how an agent behaves. They do not define how multiple agents collaborate. So this is out. Correct answer is graph-based workflow. Why? As in our demo, we defined a workflow using document review agent, fraud assessment agent, decision agent. The workflow decided who runs next, what data get passed, the order of execution, agent orchestration. That's exactly what a graph-based workflow does. What is Microsoft really testing? Microsoft wants us to understand the difference between agent performs the work versus workflow coordinates work. The agent do the task, the workflow manages the process. Exam tip: when you see questions about agent working together, passing information between agents, state handoff, agent routing, multi-agent orchestration, think graph-based workflow. Let's quickly eliminate common distraction. Thread. Thread is nothing but conversation history. It keeps chat context. It does not control agent flow. Vector store is nothing but knowledge. It helps retrieve information. It does not decide which agent runs next. System message. System message is behavior. It tells an individual agent how to behave. It does not orchestrate multiple agents. Graph-based workflow is nothing but orchestration. It controls agent routing, data flow, control flow, state handoffs, agent collaboration. Before you go, I would love your feedback. If there are any Azure AI Foundry, AI agent, workflows, RAG, prompt engineering, evaluation matrix, or AI-103 topics you like me to turn into future practice questions, leave them in comments. If you spot a better enterprise example or see something new in Azure AI Foundry, let me know as well. Your feedback genuinely helps me create more practical and useful content for the community. If you found this video helpful, please consider subscribing so you don't miss future AI-103 practice questions and real Azure AI demos. Thanks for watching, and I'll see you in AI-103 practice questions 16.